My name is Jason Cow. I'm the head of security research and solutions at CloudQuery. We're a small Series A that does an ETL layer, common use case are asset inventory, open source CSPM, FinOps, etc. And I'm here to talk to you today about scaling identity and access in multi-account enterprises and complexities and strategies for effective IAM. Before I like to move on, I'd like to call out a few things. I think there are a couple trends we saw earlier today. Will and Devin from HashiCorp talked about IAM, and I promise us three did not plan this together, but I'll continue a little bit of what they talked about, how some of the more nitty-gritty pieces of IAM and some of the complexities there, as well as some of the things we learned about earlier today with all the other excellent speakers today. That being said, another slide title. But what we're going to talk about today and the agenda, and this is very high level, we're going to go through an overview of accounts and multiple accounts, specifically AWS. We'll talk about security risks of multiple accounts. And lastly, we'll talk about securing multiple accounts, which includes identity and access management, as well as account architecture considerations that impact IAM. So let's get started. A background to multiple accounts. This is the only multi-CSP thing. You'll see are multiple different CSPs, cloud service providers, but let's talk about what accounts may look like across the CSPs. We're all familiar with the basic building blocks of cloud. So S3 buckets, Azure storage, Azure Cosmos, BigQuery, GCP, AWS DynamoDB. These are all different types of resources we can have, right? Then we go into EC2, et cetera, compute, Lambda for serverless. But throughout these, right, these are the basic building blocks. Above that in GCP, we have projects, which is their terminology for accounts. Then we have folders and organizations. In AWS, it starts out resources, builds into accounts, then organizational units, which are groupings of accounts, and then possible more OUs, and then organizations themselves. And in Azure, this looks like resources, resource groups, subscriptions, and then management groups. So why does this matter? What do multiple accounts look like? And this is a study done by Orca Cloud Security in March of 2023. They found that 63% of AWS users have multiple accounts. In Azure, and this is not a typo, 63% of Azure users have multiple accounts, same as AWS. And in Google Cloud, 65% of Google Cloud users have multiple accounts. Now that's a lot. So for reference, this is a multi-account architecture. I pulled this from AWS. What we see here is within this multi-account architecture, we heard about organizations earlier, right? This is a sample org, but there's a management account, which is a management account of the organization, and there are different OUs. So security is an OU, prod is an OU, sandbox, workloads, et cetera. And then you'll see some of the accounts within there as well. So we talked about access earlier. Well, not we, people talked about access earlier. And one of the things we'll look at, right, and this is a very simplistic diagram, but what does access to accounts look like? We have use cases, again, this is fairly simplistic, human versus machine identities, vendor access, platform teams, break glass, application teams, applications, et cetera. There are different types of IAM principles in AWS, such as IAM root user, the IAM user, the IAM role, as well as federal identities. So as you can see, this account access can get very complicated, even within one account itself. So what does that look like across multiple accounts? Before we get there, we'll talk about types of accounts. We talked about management earlier, as well as other types of accounts called member accounts. We'll spend a little bit of time later talking about delegated admin, but in this case, right, we have the management account, which is an account used to create the organization. This is the first account you typically use. This account has certain privileges that can affect member accounts. Then there are member accounts, which are the non-management accounts in the organization, and these can only belong to one organization at a time. Lastly, and this is a subsection, is delegated admin, which is a recent feature by AWS, where member accounts can be designated as a delegated administrator account to administer and manage tasks in AWS services that may span across accounts and integrate with organizations. So we take a step back and think about this. Our delegated admin accounts can actually be used to defer usage or reduce usage of the management account, which is great. We'll talk about that later as well. And why is that important? Because the management account has unique impact. If this is fully enabled in an AWS organization, it has a lot of functionality that has a larger blast radius than just the account itself. For example, it has organization level functionality that can affect all member accounts in a broad scope of influence. Created member accounts, and again, that's not invited ones, come by default with an organization account access role, which comes with the default ** admin access. If you're familiar with AWS IAM, that means everything is allowed in the account, and permits a management account to assume it as well. So the root of the management account is on the trust policy itself. SCPs, service control policies, do not apply to the management account. And then a few other things, right? The organization or the management account has organization visibility into member accounts and other reconnaissance activities. The management account also has organization management features such as SCPs, enabling, disabling security features, AI opt-out policies, et cetera. tagging, and all the member accounts as well. So let's take a pause and think about delegation. How do we do this? Again, not simple in AWS. There's actually multiple different ways to do this. There's delegation via organization actions. So this looks at organizations, registered delegated admin. Delegation via service-specific actions. A note here that the verbs used are actually different as well. So care must be taken to look at exactly what these actions may look like. So guard duty, another security service in AWS, enable organization admin account. CloudTrail for logging, register organization delegation admin. And lastly, there's delegation via resource-based delegation policies, which is relatively new as well. And that's something via organizations put resource policy. So what do all these things do? We alluded to this earlier, but what's the impact? And these are some of the services, not a comprehensive list of things that support delegation. And this list is still growing today. AWS is still releasing features, every couple months of what services actually support delegation. For management, there's CloudFormation stack sets, which allows us to deploy resources in multiple accounts. There's service catalog, right, using an IT service catalog to manage some of that as well. Security services such as guard duty, networking services such as AWS Firewall Manager, and lastly, what we talked about, policies and tagging, right? So we can use service control policies from a delegated admin through the resource-based policy, and also resource tagging accounts. And again, right, one of the things here is that we can actually tag accounts, we can tag OUs, as well as a different type of resource tagging in AWS. So now that we've gone through a really quick crash course on multiple accounts, delegated admin, things like that, let's talk about some of the security risks of multiple accounts that we see. Some of these diagrams may look somewhat familiar to you because they're somewhat simpler use cases. We'll talk about some of the pros and cons, or some things that come across with some of those things as well. So the first one is very straightforward, resource-based policy. The common use case is there's an S3 bucket we're trying to share across multiple accounts where accounts may have access to it. Very straightforward use case. We're not looking at KMS at all here. But what happens, the S3 bucket will have an S3 bucket policy, an IAM role in a different account, can access S3 bucket policy, assuming the permissions account A permit it, and also assuming the permissions account B on the S3 resource-based policy permit it as well. We also have multi-account IAM. In this case, we're using DynamoDB as an example because DynamoDB is one resource in AWS that does not have a resource-based policy. Additionally, it requires IAM access to actually access DynamoDB. So in this case, we'll assume a role. We'll take a role in AWS account A, assume a role in AWS account B using STS assume role, and then the role in account B has access to the DynamoDB table. Keep in mind that there's no way today for account A to anything in account A to directly look at the DynamoDB table in account B. So this looks, again, similar to the last slide, but there's lateral movement across accounts. We can start with AWS account A, and let's say I can jump to account B. I then can laterally move across accounts. We can make this a little bit more impactful by adding environments to it. And this is something we've seen in the past where I can start in a development account in AWS account A, and maybe because of misconfiguration, the CI/CD, other types of misconfiguration, I may be able to jump and assume role in account B and possibly have access to production data. This is something we want to avoid. Because typically, right, our controls in production are higher than, are more fortified than controls in development. One of the things brought up earlier was principal chaining or role chaining. Another complexity in AWS, we cannot role chain via console. We can only role chain through API or CLI. And this allows me to chain from a role in account A into a role in account B, and then I can chain further into a role in account C and possibly another role in account C as well. So anything more than one hop, right, you'll see in console as a switch role on the top right corner, I think, if you pull down. But this is only possible in CLI and API, which makes things a little bit more complicated to track. One of the things that AWS offers as a service perspective is something called Resource Access Manager. It's basically exactly what it sounds like. It allows us to share resources across accounts. In AWS, one of the things we can share is a networking construct called a VPC, and specifically actually the subnet itself. There's a little bit of a difference in complexity in AWS where different resources can actually be shared across different organizations. In AWS, the VPC, the subnet, can only be shared within your organization itself. So both accounts or any account sharing, it must exist within the same organization. In this case, account A and account B, let's say they're in the same org, they'll share the VPC and they'll share the subnet, which means that both accounts can technically deploy resources into the VPC, and those resources can possibly talk to each other. Again, this isn't great. The next piece is a little bit more complicated. AWS Identity Center, formerly known as SSO. It's one of the newer services. I actually had a conversation in the hallway earlier about how SSO was rolling out different types of features and how we could implement it or how people could implement it well. And SSO Identity Center basically allows us to control identities or manage this federation across multiple different member accounts. So in this case, we'll talk a little bit more of the impact there. This is a relatively new area where there is impact for identity vulnerabilities across multiple different accounts or a larger blast radius. What happens is there's a management account, typically either organization manager or delegated admin, that manages the identity center across all the member accounts within that org, and that possibly can govern access, and we'll talk about that in a bit. So with Identity Center, there are 6 different security risks I'm listing here. There's privilege escalation via permission set modification. There's privilege escalation via adding permissions, scope change via account assignment, membership modification, permission modification by removing or deny. That's done by using deny policies, et cetera, in AWS for permission boundaries. And there's also access disruption. So let's dive into it. Privilege escalation by permission set modification. In Identity Center, to apply permissions, the call SSO permission set must be called, and that modifies the permission set across whatever it may be. There's also adding permissions. Another complexity here is that if we look at the actual actions here, there's attach manage policy, which is attaching AWS managed policy, as well as attach customer managed policy, which is again, customer managed policy, which is very different from what it looks like in IAM. There's also the ability to put an inline policy to permission set, which is another inline policy we see, but this is actually tied to an SSO entity. We can also detach a managed policy from permission set, detach a customer managed policy reference, delete the inline policy, and also delete the permission boundary from the permission set itself. We also have scope change via account assignment. This is SSO create account assignment. And then we also have membership modification via identity store, create group membership, and SSO directory, add member to group. Keep in mind here that for the membership modification, there's actually 2 different service prefixes. One is identity store, and 2 is SSO directory. These both actually do very similar things for modifying membership to Identity Center. And the last 2 things we want to talk about for disruption are permission modification. So one, I can add the permission boundary to the permission set and basically reduce the effective privileges, and also permissions from like the previous slide of adding permissions of any of these actions here. So the way I think about that, right, is if we have, let's say, break glass access, there's a security team that has access across all these accounts. If I modify their permissions or even disrupt it, right, they may not be able to look through or do incident response. It gives me a little, as an attacker, a little bit more time in the account. We also have access disruption, deleting permission set and deleting the account assignment. Sounds like what it is, but these are all different ways to disrupt access in the account itself or mess with Identity Center and how it's set up. So that was a quick overview of some of the attacks. I know I went through rather fast. If you have more questions about some of that, we've done some research on delegated admin as well as more in Identity Center. Happy to share those as well out. So we'll now talk about how best to secure these accounts via 3 things: identity access management, account architecture, as well as monitoring and how to monitor this. So this is a very high level slide, probably all principles you've heard before. We look at reducing blast radius, eliminating role chaining, setting boundaries to reduce overprivilege, least privilege, and reducing unnecessary access. So one of the things that we looked at was IAM condition keys. Fairly straightforward, right? In AWS, the ARN is a building block, right? It stands for resource. Above that is the account, above that is organization or unit, and then above that is organization. So we can see these as like basically circles of trust. For IAM condition keys for the principal, and again, this is, if we're trying to scope the principal down, looking at, let's say, resource-based policies, I can scope this with AWS principal ARN for the ARN, AWS principal account for the account. This is a little bit different for OUs, right? AWS principal org paths, where I can use pathing, right, to say these OUs or these accounts are allowed to do this. And then the organization piece, which is AWS principal org ID. One example is if you have an S3 bucket, let's say everyone in the organization needs access to it, which they may need. You can use AWS principal org ID to actually protect that and only ensure that accounts within that organization can access the S3 bucket. The next slide is resource scoping, somewhat similar, but in this case, right, we're looking at IAM policies themselves. For the IAM condition keys and how to reduce this and scope it down, we do a direct listing in the ARN. So think about, putting a specific SQSQ, right? Putting a specific S3 bucket, which may not have the account number in the ARN. We also do accounts, right? You can say AWS resource account. You can say AWS resource org paths for OUs, and we can also do AWS resource org ID for organization. So this can be done in, let's say, an SCP. This can be done in an IAM policy and say we can only access resources within the organization themselves. And lastly, very quickly, there's a lot of good research on source identity and confused deputy. AWS has actually updated a lot of their documentation, which is great for how to create some of these policies themselves. But the condition keys for AWS source ARN, right, saying that this service can only access something on my behalf if this is the ARN that matches, or saying that this service can only access something on my behalf if it matches the account. And these are ways to prevent confused deputy attacks from happening. There are no condition keys today for OUs or organizations. So we talked a little about delegation. This is a sample policy, but these are, as of whenever this article is written, this research was done, all the delegation actions that you may see for different types of services as well as accounts. So in this case, right, you see detective, there's EC2, security hub, inspector, also, this basic things that are necessary, right, enabling AWS service access, organizations list, describe, but this policy permits someone to basically help manage delegation within the management account itself. And we can use this to say this is the only, maybe possible role that we want to have access to this. Additionally, we talked about Identity Center, and these are all the actions that are used to manage Identity Center itself. Something we could do here is deny Identity Center management, deny that on, let's say, an SCP, or let's say deny that on a permission boundary to make sure that only the right administrators or security team can manage Identity Center itself. And the last section of this talk, we'll talk about account architecture. I'm not advising ripping out accounts and changing and moving resources around. One of my colleagues previously likened moving things within accounts to basically slamming your face in broken glass. It's very difficult, not very easy, especially if things are running in production. Across this, right, we want to look at a few things, including AWS organizations and multiple accounts. We want to reduce the usage of management account, which also includes using delegated admin. We want to leverage delegated admin accounts. And then again, reducing direct access to the DA accounts and management accounts as well. An example architecture, very limited set of accounts, is here. What we can have is we can have the organization delegated or organization management account. We can delegate admin out based off different purposes, right? So we can have a security delegated admin where the security service may sit. We can have a logging delegated admin where the logging may sit, such as CloudTrail. And then again, we could have like a platform delegated admin. One example is using AWS Backup to back up all of our resources. You can put that in the platform delegated admin account if it makes sense. And then, right, we reduce access to these accounts so they're not blended in with the member accounts here. Additionally, we can separate things out and say, okay, do we want to have separate OUs? So one of the, I think, things that we see is there a production OU for only production accounts, QA OU for only QA accounts, and then development OU for development accounts? And what we can do here is we talked about some of the condition keys earlier, is use the condition keys to say that production accounts can only talk to production accounts. This set of accounts can only talk to dev or something like that, and use those principal org paths to really protect and reduce some of that cross environment access. Another one is accounts by use case. I think some of you may have seen this, but AWS recently released block public access for EC2 AMIs or AMIs, depending on how you say it. There's also S3 BPA or block public access. But what we can do, right, is if those are turned off at the account level and use that as, hey, I only want to put public assets in there, and then everything else will still have that BPA turned on at the account level itself, is one way of doing things. Again, it may not fit your use case, but it's one specific technique that can be used to reduce the amount of accounts that have block public access turned off. And then we can set up possibly production shared services, production OU, QA OU, QA shared services, development as well. So last piece is monitoring. How do we monitor this? And we can monitor a couple different things. Something I really like is maintaining the chain of access within cloud environment. So tracing when someone jumps, where they go and where they're going in the accounts. We also want to monitor these new changes, right? Looking at identity center changes. And also monitor account and organization changes. In this case, delegation and resource sharing too. This is an advanced feature by AWS called transitive session tags, but one of the things we can do is actually chain all this together via tagging. There are other solutions out there that don't require tagging, especially transitive session tags. But basically, when I'm chaining my roles across multiple accounts, if I pass in these transitive tag keys, it goes to every single session and we'll always have those, which is really nice for maintaining that chain of access or monitoring that in the future. I can also look at monitoring account delegation. So this is an example in CloudTrail where we're looking at enabling delegated admin for organizations, specifically firewall manager, guard duty, Macy, and inspector. And these are some of the calls you'll see that we alluded to earlier as well. Monitoring this in CloudTrail, ensuring that if this is happening, we know exactly why, is also very important. So in conclusion, not trying to scare anyone off from multiple accounts, I really think that it's the way forward. We heard some presentations earlier about a lot of accounts, many organizations as well, and some of the limitations there. But to ensure that we practice security practices and ensure we have security over those, we can reduce the possibility of risky multi-account IAM combinations. Additionally, again, not trying to say change your account structure, but design with the future in mind, right? And manage this account infrastructure design, looking delegated admin, looking at our access to the management account, et cetera, for some of the reasons we mentioned previously. And lastly, monitor multi-account actions such as resource access manager and maintain that chain of access across the board. Thanks for your time.